Uh, Today we'll kind of switch here a little bit and talk about the version control and how to use Git. It's kind of like not exactly related to system skill, but it's a tool set that is kind of essential for your life as a programmer. So we'll go into the details on how it works and how to use it. But before we begin, let me thank Ajahn Sansan on helping us set on the setup for the server, right? So he basically make a public facing site of the IP address, or I mean the server name actually that you can join. Then that server will basically tunnel all your packets directly to Syscale. So you can use your username as we discussed last time. Basically, it's going to start with the letter U followed by your student ID. Here's the server name. So if you use a Mac and here's the port 2222, so if you use a Mac open terminal, type in exactly as this without the bracket. Basically, type in SSH-P 2222 U number at syscale.cs.musu.io. If you're on Windows, you first download PuTTY, then use the syscale.cs.musu.io as a server name on the text box, and then use 2222 for the port. Warning, do not use VPN. Do not use MUVPN. And one more thing, the password, I'll type the password on the chat. So here is the password. Right, so you can use that password to log into the machine. That's it. So I'm gonna go back to the slides again toward the end of this class, right before you do in-class exercise 2, so that we can make sure that everyone can log in and can work through the in-class 2. All right. So let's switch gear and talk about the version control systems. Let me first motivate a few things that can happen in your life, right? So imagine that let's say you're working on a group project and you spend the last 7 days cramming your code in, you finally get everything to work and hoping that you can do a pilot run, right? Create a directory to store results and everything. Make a typo when you type in the command and you type that in. Remove -rf star. I mean, yeah, it will actually delete everything, right? In that current folder. Because you're sleep deprived, you just happen to hit that, even though your brain command you not to, right? And you get sad. So this is one case that, I mean, might not exactly happen like this, but it can happen to some extent. You can accidentally delete files. Another thing that can happen, let's say the same setup, like work on a project. You finally get everything to work. You spend time trying to get rid of that one bug, the one last thing that you detect. And this is actually pretty common, even in your assignments, right? You have bugs and you try to get rid of it. What happened is you eliminate that bug, and it just happened that that bug that you get rid of, the code you put in turns into 3 more bugs. And then you create 10 more bugs when you're trying to debug the last 3 bugs. And you sit silently in the corner, wishing you can revert back to the version with 1 bug, right? Because now that hopefully you know what happened with that bug and how to fix it so that you can actually correctly fix it. Or at least you were hoping that you can compare the 2 versions. Right? So hopefully these are some of the things that motivate you from knowing how to use version control. And these are additional scenarios, right? I've seen students saying, hey, I swear my code worked yesterday. And yeah, I mean, computer programs are deterministic. If you run it, it worked. If you run it again, it should work. Unless you write a really complicated multi-threaded program, it would behave the same every time you run it, right? So make changes that break your code, you somehow wish you can go back in time, right? I shouldn't delete and rewritten my code to to introduce more bug, or things like your computer crashed, right? And I lost all my work, or you work with a friend and he accidentally deleted my code. This thing make you sad, right? And you want to use version control to make sure you are less sad, right? So you have some version you can go back to. Uh, so let me ask you this. What's the most primitive form of version control? How can you make an like version your program? Anyone want to take a stab and tell me what's the most primitive one? Controls, you mean copy and paste, right? You can copy the folder, paste it in some archive location, and undo. Yeah, actually, that's a great example that I didn't think of. Yeah. So let's say you type things in Microsoft Word, you click undo, right? It would go back to the older version. Yes. So that would work too. Uninstall and reinstall again, right? Obviously, that would work, but it means you have to create installation files every time you want to have a new version, right? But this version control technique uninstall and reinstall things, right? The installation files is the version control for the company, right? To have say Windows 95, Windows 98, Windows what's next? ME, Windows XP, right? Different version comes with different installation files. They install the program that are built for each version. Those are not as primitive. The most primitive ones are essentially make a copy of the folder, right? So why is that bad? Why is Control C, Control V on a folder a bad idea? You essentially get flooded, right, with the same folder but different version, and you have no information on like, okay, what's going on in each of the version, right? So at some point you're gonna get overwhelmed and like, okay, which version should I use? Which version has the least bugs? Which version is perfect, right? So here comes version control system or VCS. The goal here is you want to track all the changes and allow you to go back in time, right? The difference between copy and paste, which generate new files for every single version, over here, instead of creating a new file, you just track the differences between the old version of the file and the new version of the file. Why does it make sense, right? Basically, it stems from the, I guess, the observation that over time, when you are writing code, you don't make changes everywhere. You only make change a few lines at a time, right? You try to add new features, you add a few functions to implement those features and add them to the main files. You add 2 lines to fix bugs. You delete 5 lines to get rid of bugs. You modify 3 more lines to get rid of bugs on a program that's 1,000 line long, right? So instead of making a copy of 1,000 lines long files, you just need to make a copy of the differences, those 5 lines, 3 lines, and 2 lines, right? Those changes. With this log of changes, you can go back in time and you can go forward in time, right? It tracks people's contribution to the changes as well. You can see who did what. Why do you care? Why do you care about who did what? It's not just because you can blame, hey, you make that mistake and now the program is buggy, right? It's not just that. You can actually work in a big team, right? Let's say you are in a company that has a team that implement different features to the program, right? One team might be working in Microsoft, like building the undo and redo in Microsoft Word and make sure it's correct, while your team is trying to work on a renderer for Microsoft Word that you can draw box and lines, right? So if you can see who make the change, you can work amongst team saying, hey, I know you added that code in. I never get to actually talk to your team on what are the exact logic and the reason why you add that code in. So I know if I need to modify the same function, I know what I'm expecting, right? I know who I talk to, who should I talk to. So these are the benefit of version control system, and here are some of the examples, right? If you are in the, I guess my generation, who is the older generation, we've been using Subversion a lot. This thing is called SVN. In a bunch of company, they'll use Mercurial, which use the command HG, which is a chemical symbol for Mercurial. And then these days, you'll be talking about Git, right? This is the popular version control system. In fact, Git is what we call a distributed version control system, where you can have a local version on your machine, your desktop, and you can maintain multiple copies across, I guess, across the universe. Your friends will have a different copy, you have different copy. Each one of them would look different. They can look the same, they can look different, it's fine. There's no need to talk to the central server when you edit anything in your local copy unless you want to sync with the central server, right? There's a benefit to that. You don't have internet connection to work on your program, right? You just need to connect whenever you want to sync up with the friends, your friend's code, right? This allows kind of like a good balance of working independently. You can work on your own on your laptop, but still you can collaborate with everyone. You can see the changes, you can download the changes, you can push your change to the server so that everyone see your changes. And here comes the concept of, not the concept of Git, but more like introduction of Git, right? It's probably right now the most popular distributed version control system. Anyone here never heard about Git? So if you haven't heard about Git, that is okay. Let me sell, I'm not a Git salesman or anything, but let me sell you the concept of version control so that you can buy that concept and use one of these software. And let me talk about the benefit of Git. It allows you to branch code out into different versions that can be worked on in parallel. So let's say you run a software company, right? The software company want to build three new features to your code. You have three teams. So you assign the first feature to the team A, the second feature to team B, third feature to team C. They can have their own version of the program. They will implement these features in the independent manner by branching out. Then when they're done, you can merge it back. Merge all the change so that your program has all three features, right? It allows a flexible workflow. You can kind of like work individually on your laptop without syncing to the central server. You need to only do that when you want to push a commit, right? Commit all the changes to the server. It actually have a built-in data integrity check to make sure that the files are correct and there's no bugs, as in like the actual letter change to one to another because of bit flips and things like that. And it's fast. It's actually pretty fast and efficient. Right? It doesn't blow up your hard drive because because of its tracking of the changes. So it's high performance. And the first concept I need to tell you is called repository or repo. You might have heard about this word repo before. What are repo? It's a collection of files and folder in the version control history, basically. The history would appear like a snapshot when you take, like it's kind of like when you bring in a camera and take a picture, right? Think of it as when you play a game, right? Before you make any decision, what do you do? Let's say I play Witcher, right? Anyone here play Witcher 3? We're not gonna talk about Cyberpunk. Let's leave it alone for now until they fix all the bugs. Uh, So let's say I play Witcher 3, right? And I talk to this NPC, the guy on the street, and I'm deciding whether I should kill him or leave him alone. And somehow this guy might look important, right? Maybe he might have something to do with the story later. What do? Save, right? You will save the game. You literally will, your instinct as a gamer would, hey, I'm gonna save the game for now, just in case I make a bad decision, right? You save the game and you literally kill that guy, or you leave him alone, or things like that, right? Also, I guess I'm not sure if I should use this example because I'm just literally saying things like you kill a character in a game, things like that. But this is called commit, right? You save the state right before you make decision. Yeah, you save before you make any questionable decisions. And in computer games, we are allowed to make a lot of questionable decisions, and you should not make those questionable decisions in life. So this is the same as I would say the how version control system works, right? Well, yes, you cannot save in real life, but version control is a program. You can program things to save the state for you, right? So, uh, let's say let's say you are trying to add a new features for a company and you're like, that's questionable, I'm not sure if I should add that features or not. Okay, let me give you a more realistic example. We all, by law, I guess, we are now required to install this app called Moshana, right? And you might have noticed they ask for a lot of permissions, right? Let's say you are the programmer for that app. You are trying to make that questionable decision whether you should actually request permission to use a camera or not, right? I mean, if you use a phone and the app use a camera, that's kind of like pretty big, right? As a user, you want to know what they want to use it for, right? So before they make those changes, they can take a snapshot saying, hey, there's going to be this version before you implement that features, right? And then you can make branches. You can make two questionable decisions in parallel, right? How many of you here play games and maintain multiple save files? Like save file 1, 2, 3, 4, to make sure all of your questionable decisions have some backup so you can somehow pick the path that's optimal for your playstyle. I do too, right? So this is the same as branching out in the Git repo, right? Before I make all my questionable decisions. Yeah, so as you said, right, in the chat, if the game gives me 20 save slots, I'm gonna use all of them. In this version control system, you have unlimited, I guess, save slots, right? You can make as many branches as possible, but it's your job to keep track of what are all in those branches. My recommendation is if you actually use this thing, make sure you kind of minimize number of branches so that you know what's going on in each one of them. But each time you save, this is called commit, right? Commit. And a repo, a repository can have different branches, each with their own history, right? In a similar to game, like I love gaming analogy because it's kind of similar. Let's say I play Witcher again, right? I can make a decision to be a good guy and save everyone in one playthrough. And then in the next playthrough, I want to be relatively bad Witcher and murder everyone, right? So I can maintain two save files, right? In version control system, you can merge these branches. We'll talk about that. And here's kind of like the high level overview, right, of the version control system. Let's say in this case, you have three files, A, B, and C. What is being stored, as you can see here, across different versions from here to here to here to here, right? They don't store a new copy of the same file. They only store the difference, the delta between the current version and the older version. So you can move from file A from here to here, from here to here, from here back to here. You can move in any way you want for each of the files, okay, for each of the files. So that's it. That's it for the high level. We'll go into the detail of how to use Git. Right? We will now start to talk about how to use Git. So the first command that I need to tell you that exists is init. Create a new repo. So you call we can call the command by typing git init. Before that, install Git first to install Git. So basically in Ubuntu you can do apt-get install Git. This would install Git on your machine, right? If you type Git init, basically it will initialize right now that folder, that current folder that you're in, as a new Git repo. And to do that, basically what it does is it creates this hidden directory called .git. Right? As we discussed in the, I think, second lecture, if you have a dot in front of the folder name or directory name, do you have, okay, that's a great question. So there's a question about, do we have to do this in the server? Depends. It depends. Basically, use it all you want, right? For our assignments, you can do that on your home directory in the server. You can use it on your local machine. You can use it on the virtual machine. It would work everywhere. It's pretty portable. You can use it everywhere. I'm going to show you an example that I have here locally on my machine that link with GitHub, right? I would definitely go through some of the examples here toward the end of the class. So now that let's say you create a new repo, another method that allows you to use someone else's repo that they already created or the one you created on a server and you want to put it on your laptop, right? You can clone them, right? So if you have existing repo, you can clone, right? So this git clone and the repo name, usually these are things like https:// if you go to GitHub, for example, I'll show you what you need to copy and paste here. It clones a remote repository into your local location, right? So here's a high level explanation of things. You have a working directory. This is your folder. And that's a head. Head is the last commit, last snapshot you save. This is your save file. If you save things, right, you create a save files and then you keep walking in the game. Like you go straight and go try to fight the boss and lose and then reload the game, things like that, right? That's the head. The head is, think of it as a save game. We call this the last commit. Index, I cannot use the gaming analogy anymore. Index is my proposed change. You can say, hey, this is a good version of the file. I'm gonna propose this snapshot, but I'm not gonna commit it yet. And here is more like a detailed example. So let's say you want to stage a change, right? Stage a change is a name that we call the instance where, let's say you have file A and this is version 1, right? The head will have file A because this is committed to version file A version 1. It's also in the index. It's there because you already planned some changes on this, but on your folder, on your computer right now, in the working directory, you have the same files, but you modify them, right? So it's file A, but it's version 2. Staging a change, move file A version 2 to here and replace file A version 1, right? Replace file A version 1. Now the index point to file A version 2. This can be done through the command git add file, add the file name in there, right? If you want to actually put this here, right, then it's called committing a change. So from the older example, right, now you have the working directory file A. Let's say it's here in the index. you type in git commit -m with some message. You move it here. You commit them -m followed by the message that you can say, this new file has new features or fix the bug or do whatever. Basically, these are the text messages that you can read afterward, right? Why is the message useful? You can use it to describe different versions of the file, saying, hey, this file fixed this bug, this file fixed this bug, this file fixed this, but add this bug, so someone please fix it. Things like that, right? These are messages you write on your own. It will actually track who commit that, so you know who to talk to if you see certain comments. The next set of command is, let's say you stage a change, right? You already stage changes. Version 2 is on the index. And you say, hey, version 2 is bad. I don't want version 2. I don't want version 2. I want to revert back to version 1. And version 1 is right here at the head, right? So you can say git reset and the file name. It basically will move version 1 and replace version 2 in the stage change. Your working directory will still see version 2. Your working directory, the one in your system, the files will be version 2. But the changes will go back to version 1. So if you commit, it will commit version 1 back. If you want to throw away version 2 because you confirm that, hey, that file is bad, you don't want it, you want version 1, git reset --hard, move it back to version 1. Another command is checking the repo status. So if you do git status here, it will tell you a bunch of things, right? Over here, it's an on branch master. Branch master is a keyword in Git saying that this is the main branch. Everyone will have access to this main branch and it will be there when you created the Git repo. Change to be commit. These are stage changes. Or in other words, this has been added by the command git add. Change not stage for commit are the files that you modified, but you haven't called git add, right? You have not called git add yet. This basically means that you haven't called git add. You just make changes without anything. It would tell you, okay, if you want to stage it, type in git add to update what will be committed, right? Press on will. This is the staging the change. Untracked files are files that hasn't been in the repo, a new file. It will say, hey, run git add on that file to include these files into what is going to be commit. Right? Any questions so far? Okay, so if you have a question, can you repeat OP4? Okay, yeah. So operation 4 is if you have a file that you make change in your folder, you type in new things, right? And you say, hey, I don't want that. I want to throw away all the changes, go back to what I commit. I want to load my save files, right? Oh yeah, sure. Let me talk about this one before I address the next question. So the first question is, can I repeat OP4? This is when you want to, let's say you play a game, you want to load your save files. You make some changes that you don't want and you want to throw that away. You type in git reset -hard. It discard all the changes and go back to where you comment, right? So does that answer the question about can I repeat OP4? Yeah, like reloading. And the next question is, you still don't understand the difference between not stage and untracked. That's a great question, right? These not stage, it means that these files was added before. this is already added before. Then you modify the file. When you run git status, it will say, hey, you modify this file, but you haven't staged them or commit them. So if you want to stage them or commit them, you need to type git add the same file. These untracked files has never been added ever, right? The first time the git repo see this file, it just gives you the warning, say, hey, I never seen that file before. If you really want to do a version control, add them. So the question is, if we modify the added files and we have to add them again for changes not staged, in theory, yes. In practice, what I will do is I'm lazy, right? I typically, when I modify the added file, I'll commit them. I skip the staging part and I just go to commit. You understand what I mean, right? Basically, here is the commit. Is the stage. And then here's I guess modify without staging and commit. Git add will move from here to here. Git commit allow you to move from here to here. Personally, I typically just git commit and it will apply all the changes. So does that answer your question? So this is git add. And this is git commit. Okay. So now let's go to the concept of branching analogy. We can have multiple save files. So here's an overview of branching. As I said earlier, the master branch, if you see, this is the main branch, right? It starts from the beginning and you'll see toward the end of this repo. And let's say you run a company, a startup, and you want to add two features, a little feature and a big features. And you came up somehow, you were running a company in like agile manner, right? Make sure you have something to deliver first and you gradually fix things. You first say, hey, I want these features. Your team say, okay, I can branch it off from here to try to add the features. Then, as the CEO of the company, you told your engineer, say, I want another features called big features. Let's say your master branches at that point. So your engineer say, okay, I'm going to branch it out, work on the big features right here. Right now, what you created are three branches. The one that is implementing little features right now, the master branch that you deliver to your customer, and the big feature branch that is also implementing a different features. Right? And you can imagine later, after all these features are implemented, you then merge it back to the master. But before we merge it, we need to first talk about switching between branches so that your engineer can work between the two features. Let's say you're poor, it's still a startup company, you only have 5 engineers. They have to work between different projects. So you need to switch the branch between the purple one to the blue one to the green one. To switch the branch, right? Let's say you're at the master. You can say git check out master to actually switch to the master branch. Git check out branch name would switch every file into that exact branch, right? Git check out followed by the branch name will switch from every single file in that repo from the branch you are in into the branch you want to switch to. Then let's say you have 2 branches and you want to create a new branch, right? You can run git checkout -b. -b create a new branch, which in this case you have branch 2, right? You have branch 2 and now you will be in branch 2. So here's a checkout example. Let's say you run git checkout master, git check out master, put you here, right at where master is pointing. Git check out some feature will put you here where the some features branch is pointing. Right? So you can use checkout command to switch between different branches. You can even switch between the remote and the local repository, right? So the remote location, let's say the master is right here, and then you clone the remote location, built in a tons of things, right? Different features, and then you have development branch where your engineer would play and toy with the software. And then another feature that is already defined. Hey, I want that feature. So you branch it out. And then the master is still going back in time, is still at that location just to be safe, that just that you can deliver to your client, right? So when you have this remote Git repo, you can actually sync the files, right? Sync the files from your local location between that and the server. So the first command is called pull, and this is basically type in git pull. Git pull will transfer the changes from the server into your local changes, right, of that branch. Git pull will make sure your local directory is the same as the head of that branch in the server. So here's the overview. So let's say originally you have this, and then the server move on. The server move on here. Git pull will move you from here to here. Git push is the reverse of that. Let's say your branch is further ahead and you want to push the changes to the server. So git push will send these changes and make it the head of the server's repo, right? So here's the overview. Let's say this is where you are. This is where the server is. Git push will move the server to the same location of where you are, which is the most updated version. And here's a summary of the workflow, right? You have the server, and this is your local directory, right? Local. When I say local, it means your desktop. It means wherever you're working at. You have the, again, as we mentioned, this head. This is the staging area, which is the index. And this is your workspace, your folder and files that you have right now, right? So if you do git add, it move from workspace to the staging area. Then you can git commit, right? Git commit -a, which is what I usually do, will bypass the staging area into the local repo. So basically, what I typically would do when I have changes in my local directory, I would do git commit -a to push it all the way to the local directory, and M for messages. Message here, right? This will allow you to move from here all the way to here. Otherwise, you need to do git add and then git commit as a separate command. Git reset, move from the staging area back to the workspace. Reset with the basically reset with the commit ID. So each commit will have its own ID. You can put the ID to revert your files back to that version. It will allow you to go back in time. Git diff will let you see the difference between different versions of the files. Git diff head will tell you the difference between your files right now and what's at the head. Git push will push from the commit to the server. Git fetch will fetch it back to the head, but not in your directory. If you want to get it all the way to your directory, git pull. And that's it for a quick overview. Right. So there was a question. So this is like he clones stuff from GitHub, but in this case, we upload the files, assignments to the server, right? So I think those are two orthogonal things. So dealing with uploading the file to the server, this is done manually. Dealing with GitHub, you need to use the git command, and this is to the GitHub server. So does that answer your question? Because I'm not sure I quite understand the question. Okay, awesome. So that somehow answer your question. All right. So the last thing we need to talk about is merging, and I put it at the end because I in I think we intentionally saved it for last. This is the if you work in a company, especially in the software that are going to be delivered, some of the engineer will be working on merging everyone code into a product. And this part can be annoying because you have to understand everyone changes and come up with a one solution, right? So what if you and your friend develop a code together onto different computer? Both of you and your friends make edits uh, to the repo, and both of you want to push to the repo. So basically, whoever commit later has to resolve the conflict, right? This is kind of the rule. Basically, the one who commit first, you can commit and update everything in the server. Your friends who have another version, you have to figure out, okay, what code goes there. So here is one example. This is the master branch in the server. You make some change, you can merge. Fast forward, if there's only one branch, you do git merge. It allows the server or the master to see the current branch. Basically, it merged the branch, and now everything points to that one node, right? But let's say you're actually branching out, right? The master now go ahead and is at this location. The development branch is here. When you have to merge, basically you're trying to make sure these two work together. The code works and have a separate node that merge the two branches together here, as you can see, right? So now master will be moving on to the next node, which combines some features and master. All right. So that's pretty much it. So let me wrap up some of the commands that we went over, right? There's a git init, initialize a repo. You can clone, you can look at the status. Git log will show you the history of who changed what. Git add, put files in the staging area. Git commit will commit your change to the local repo before you can push. Push allow the changes to the remote location, and pull will change it from the remote location back to your local repo. Git checkout will retrieve a specific version of the files. One last thing before we move on to some of the demo. Assignment one will be out tonight. You have 2 weeks to work on it. Basically, it will be due Friday, 2 weeks after this, 2 weeks after today. Basically, you have 2 weeks and 1 day to work on it. Next week, we'll start going into C and we'll learn how to use C. All right, so basically that's the end of the lecture material for today. Before I go to the demo, so let me stop the recording right now.